All right, so we are going to solve and graph some inequalities today. So we're going to start by just looking at equations, and then we'll show you how it's the same and a little bit different than inequalities. So if it says solve and graph, I have x plus 2 equals 5. How do I solve for x? You guys can just say it.
Negative.
Yeah, so minus 2. We want to subtract 2 from both sides. All right, so we get x equals 3. We don't normally graph solutions to equations because it's not very exciting. There'd just be one dot on 3, and that's it. So normally with equations, we don't bother graphing them. When we do inequalities, though, there's a lot of solutions, infinite solutions, and so we do usually do a graph for these. So now instead of equals, I made it less than or equal to, but the steps are the same. We're just going to subtract 2 from both sides, and then instead of equals, I have less than or equal to 3. So that's my solution I'm going to box. And then when I graph it, I just have to ask myself, okay, at 3, am I going to fill in the circle or not? Fill it in, and we fill it in because we have that equal to. That means 3 is a solution, and then any number smaller than 3 is a solution, so everything this direction is a solution. And we talked about when the variable's on the left, this symbol is actually the arrowhead down here and can help us figure out. So 3 is not this only had 3. This has 3 and 2.5 and 1.8. And all of these numbers off into infinity. Negative 100 is a solution to this. So any number to the left of 3 works. And this is why they come up with the graph. So you can visualize all the numbers that go forever that could be a solution to this. So under here, we're just going to write one solution. It's just that point right there. This one has infinite solutions, which means that the solutions go from 3 to the left forever and ever and ever. There's lots of solutions. Anything on that arrow to infinity and beyond. Okay, so there's a little bit of review on graphing, which we'll just do really quickly, but we just learned this, so it won't take us that long. So if I want to graph x is greater than or equal to -2, I go to -2. Do I fill in the circle?
Sure.
Yes, good job. So we fill it in. That's because it has that bar that means equals. And then this little arrowhead is showing me we're going to shade everything to the right. So my arrow is going to go to the right. It's just habit for me to go all the way to the end of the number line. You could actually put the arrow somewhere sooner, but that's where my solutions are. And then this is numbered 1, 2, 3. I'm just going to do number 3 next because it's over here. So I have x is less than 2. So since I don't have that equal to bar on the 2, I'm just going to make a circle that's not filled in. And then it's less than. So I'm going to shade in all these numbers and make an arrow showing all these numbers to the left of 0 are solutions. Number 2 down here, we have x is less than or equal to 3. So on 3, we do fill in the point. That's because this bar means equals, and 3 is part of the solution. And then it's less than, so we're going to go out this way. And then on number 4, we're going to go to -1. It doesn't have an equal to, so I'm not going to fill that in. And then x is actually bigger, so all of my solutions are going to go to the right of -1. So this is just reviewing what we've been working on. We have done these before. And then on the rest of these, we'll have to solve. And there's just 1 or 2 of these in each box, so this won't take very long from here on out. On my recording, it's going to sound like Darth Vader. All right. So down here on solve and graph the inequalities, we just have to think about it like it's an equal sign, but then we have to make sure that we're using the symbol that's there. So pretend that this is equals. We're trying to get x by itself. How do I get rid of the 3? -3. He's signing it to me, -3 on both sides. And so I'm going to have x is less than, and then this is basically -7 and -3 together, which makes -10. So this is my solution. And then I graph it. Now, when you have to, if you have to make a graph that's not already made, I'm not going to make you number everything forever. We're just going to put -10 on here, and then 0, and maybe we'll put 10 over here. We're just going to number by tens. That way we can make this graph really easy. So x is less than -10. We just have an open circle here. We're not going to fill it in. And then we're going to shade an arrow off to the left, so any number to the left of -10 works. Okay, sometimes they're going to be tricky and they're going to put x on the other side. So on the next one, the x minus 6 is over here. First, how do I solve for x? How do I get x by itself? Okay, so he's saying to me plus 6. You guys are funny. It is okay to say things out loud when we're recording. So that cancels this out. So x is still over here. And then this symbol is still going this way. So I'm going to copy that symbol just like it is. And then -4 plus 6 is 2. Now remember, if you're using that shortcut where this is the arrowhead, if the x is on the other side, we're going to go the opposite direction. So I'm going to put just 0, 2, and 4 on my number line. I'm not going to make it fancy. I don't need a lot of numbers. I just need 2 on there and a couple other numbers. So I'm going to go to the 2. This does have an equal to bar, so I'm going to fill that in. Now this is switched, so I'm not going to go this way. I'm going to go the opposite way. And I can also use a test point. So since this is 2 and I have my solution here, maybe I'll put in 1. Does 1 make that true? 2 is greater than or equal to 1. Yes, that works. I could also put 1 up here. 1 minus 6, is that less than or equal to this? Yes, because that'd be -5. So you can check this by taking any number on this arrow that you drew and put it back in and just make sure, hey, it works. But it also works if we're using this arrowhead, if the x is on the left side, points the direction you're going to go. We talked about this symbol being the arrowhead. That's where it comes from. But when they switch it and put x on the right-hand side, then you've got to remember to go the opposite direction. If you can keep all that straight, then we're good. All right, so moving along to number 3. If we're solving for k, how do I get rid of the 8? Okay, so -8, good. So my k is over here again. It's on the right side. And then on this side, we're just putting -5 and -8 together to make -13. So that's my solution. And you want to make sure if the k is on this side that you're dropping it down on the side it's on. Don't flip this all around and get confused. So on my number line, I'm going to put -13 here and then 0. I'm going to pretend I'm counting by 13s because I'm lazy. And just put a couple numbers on there. And then would I fill in this circle or not? No. Good job. Because there's not an equal to bar. -13 is not part of the solution. Now this arrowhead's pointing left, but k's on the other side from what we learned for. So instead of going left, we're going to go to the right. And then I could pick numbers to just see if this works. So maybe I'm going to pick +13 and put it in up here. So I put +13 up here. That would give me 21. That's definitely bigger than -5, so that would work. So I could just quickly check it by taking any number over here, putting it in where k was, and just seeing if it works. Okay, so then over here on number 4, to get p by itself, I have to get rid of -3. So this is the last one like this. We're going to add 3 to both sides. So we'll get p is greater than 12 as my solution. And then on my number line, maybe I'm going to count by 12. So I'll go 0, 12, 24. You can do that however you want. Just make sure 12's on there and you've got a few numbers. So on this one, we also do not fill in the circle at 12. 12 is not part of the solution because 12 cannot be bigger than 12. And then the variable is on the left side, so this arrow will show us which way to graph, so we can just shade the arrow off this way for our solution. So any number out here works. So I can take any number bigger than 12 to put in for P. So maybe I pick like 20, and I put 20 in here. So negative 3 plus 20 would be 17. That is bigger than 9, so that checks out. You don't have to show me this on your paper, but it's good just to mentally know. That's a good way to see if you've put the arrow the right way or not. Pick a test point. Okay, so we were using adding and subtracting on the first few. Now we're going to look at multiplying and dividing. And this is where our little twist will come in. It's the only thing that it's really different than solving equations. The first two are okay. So it says solve and graph the inequalities. And there's our objective. We're solving and graphing simple inequalities using multiplication and division. So if I have 4x on this side, how do I get x by itself?
Minus.
Not minus. So this is 4 times x. What's the opposite of times?
Divide.
Divide. So we're going to divide both sides by 4. So that cancels this out, and we get x is less than or equal to 5. It's really easy to want to put equals here because we're used to writing equals. It's not equals. It's less than or equal to. And so then if we make a number line, I could do 0, 5, 10, just whatever numbers I want to have on there. I could then go to the 5. I'm going to fill in my point because 5 is part of the solution. We can have equals, and then the arrow is pointing left. So all of my numbers to the left would be what's less than 5. Because we want this number to be smaller than 5 because Pac-Man's eating the 5. It's bigger. So we want all the numbers that are smaller. Okay. So on number 2, this is x divided by 3. What's the opposite of divide? Times. So I'm going to take this, I'm going to write it out as a separate step because it gets confusing. I'm going to take this side times 3, and that cancels out the divide by 3. And then take this side times 3. So that's going to give me x is greater than negative 6 for my solution. So on my number line, maybe I'm going to put 0 over here, and maybe I'll have negative 6 and negative 12. I'll just count by 6s backwards. And then do I fill in the circle at negative 6? Do I fill this in?
No.
Nope. Good job. And then which way is the arrow going to go? You can just use your thumbs to show me.
Where?
So on this, which way is it going to go? Okay, so it's going to go, yeah, so on the screen, the way you guys are looking,
right.
you've got it right. Yeah, I had to think about that. Oh, wait, they're backwards for me because I'm turned around. So that would be correct. And all of these numbers are bigger than negative 6. So if I picked any of the positive numbers over here, any of these smaller negative numbers, they're all bigger than negative 6. So that would be true. All right, so the one big twist, the only thing that's different from equations, we're going to talk about in the next couple of boxes. So it says inequalities transform like equations except ... It's like dun dun dun. So we start just like we normally do. So if I want to get x by itself, it's negative 3 times x. What's the opposite of times? Divide. So I'm going to divide by negative 3. The only thing that's weird is when you divide by a negative, this side was negative, but that's going to cancel out and give me positive x. This was positive 6, but when I divide a positive by a negative, I'm going to get a negative. So all of my signs have switched. So what's going to happen when we're switching negative to positive and positive to negative is this has got to flip. So I call this flip. You can say the sound with me, flip. We flip it. And then that's going to be my solution. And it's just because these symbols change. So I'm not going to graph this one. We're going to write information. If you multiply or divide by a negative number, I'm going to make big and bold flip I'm just going to put flip the symbol. It's actually the inequality, but I'm too lazy to write the whole word inequality because it has 5 syllables. It's just, so I'm just going to put symbol. So we're going to flip. And so this is a big deal. And I'm going to take a highlighter and just sort of put a box around this, that this is a special case. If you multiply or divide by a negative number, so it's that negative number that matters. So the one that we did back on number 2, this one over here, was okay because we were multiplying by 3. This one over here on number 1, we divided by positive 4. These are okay because we're dividing by a positive, we were multiplying by a positive. It's only if you're multiplying or dividing by a negative and all of those signs start changing. And it's because the relationship on the number line actually flips. Because bigger negative numbers are actually smaller and bigger positive numbers are bigger. And because it's sort of going opposite directions, we have to keep track of that. So on the next page, we're just going to cruise through these. We've got a couple of examples. So now I have negative 4x is less than 24. So I'm going to divide by negative 4. And that's when your brain's going to go flip, flip, flip. And so I'm going to go ahead before I write anything else and flip this so I don't forget. And so this negative 4x changes to positive x. And positive 24, when I divide by a negative, becomes negative 6. So it's because all of the signs are changing. And then we can go ahead and graph this really quick. Maybe I'll put negative 6 and 0 and 6 on there. We're just trying to do this quickly. On the worksheet, you guys will be glad to know there are number lines already drawn for you. So that'll save you guys a little bit of time. So then the circle at negative 6 is not filled in because there's no equal to bar there. And then we want numbers that are bigger than negative 6. So we're going to go this way. And you can also think about this being your arrow. This is the design. This is supposed to be an arrow pointing you to the numbers that we want for the solution. All right, on number 2, we have y divided by negative 3. So to solve that, I'm actually going to rewrite it just so I have this neatly in my notes. We would multiply both sides by negative 3. So that cancels out the negative and makes this side now positive. But this side just changed to negative 21. So everything, oh, and so I need to flip the sign. I almost forgot after I just said it. So we're going to flip this. It was pointing this way. Now it's going to point this way. And so we did have to flip. I'll just write flip there. And then flip. Have that in our notes. And that is the one mistake that people make. When I was working with the juniors this year, and we were doing SAT prep, and we had all these practice tests, the thing that showed up in all of the problems like this, they usually didn't do the graphs. They usually just had this part, and you had to find the solution. They were trying to trick you and see if you knew that you needed to flip the symbol almost on every one. So somebody out there thinks it's important. All right, so I'm just going to do negative 21, 0, and 21 on my graph. Do I fill this one in?
Yes.
Yes. Negative 21 is part of the solution because we can be equal to negative 21. And then we actually want the numbers that are smaller than. And if you're not sure, you're like, did I flip it? Should I do this? It's a test. She's not going to help me. You could pick any number out here that you want and put it in. So I want to pick something that divides by 3. So let's say I pick out here negative 30 to try. And let's say I put that up here. So I'd have negative 30 divided by negative 3. That would be positive 10, which is definitely bigger than 7. So I can pick a number out here, any number I want, that's just easy, to make sure that I shaded this the correct way. And so that's just a good way just to check and make sure that in the original problem, something out here in my solution works. All right, so we're going to go through a couple tricky ones, and we're going to see if we need to flip or don't flip. It's like a game show. Flip it or don't flip it. All right, so on number 3, what do we do to solve for x?
Divide.
So we're going to divide by 3. Now I'm dividing by positive 3. Do I need to flip it?
No.
Just a minute. No, because this is positive 3, this is positive, it's staying positive, this is negative, it's going to stay negative. Okay, you can go. And so then on my number line, I'm just going to pick a couple of numbers. So x is less than -6. I could put my circle at -6. I don't fill it in because I don't have that equal to bar. And then everything less than would go over here. And so anything less than -6 is just going to be more negative than -6. So I could pick something easy like maybe -10 out here to put in. I could take 3 times -10, which would be -30, and that is smaller than -18 because it's further left on the number line. All right, I'm just going to go ahead and do this one, and we'll catch him up when he gets back. So if there's a negative in front of the fraction, there's a really cool trick where we can actually move the negative down here with the 2. As long as there's only one negative somewhere in the fraction, that's okay. And the reason we want to do that is we want to solve this in one step. And that would just be multiplying by -2. There you go. So then m is less than -12. And we can go to our number line then. We'll put -12 and just a couple other numbers on there. We don't fill this one in, and we want all the numbers less than. I'm going to make this arrow a little longer, like that. And that shows me where my solutions are. So I can check this by taking any number out here. So let's say I pick -20, and I put it back up here. So I'd have -20 and essentially -2, which would make positive. Wait, did that? Oh, we forgot to flip the sign. Oh no.
Flip it.
Flip it. I know, I got excited. We multiplied by a negative, so we need to flip it. So guess what? I just realized by trying to check -20 that didn't work. Teachers make mistakes too. It's a good thing. Because then it makes you not feel so bad. So I actually numbers bigger than -12. So we'll pick one of these. So if I pick, let's say I pick +12. And divide by -2, that would be -6, which is less than +6. So I could just take it over here and plug that in, and that works. Sort of a little side note there. And so if you want to, you can always check this, and that'll help you know if you shaded the correct side. It won't necessarily check your math here, but it will help you check the sides. All right, so we're just going to add steps in. We've solved all kinds of equations. So it just all kind of hits on the same day with inequalities. Those are all one steps. We're going to do a couple 2 steps, then do some with distribution. It's just with less than and greater than instead of with equals. So it's like a big review. So on this one, when I want to solve for x, the first thing I would do is add the 5 because we want to get the part with the x in it by itself. So then I bring down the 2x. This is now canceled out. I have less than 11 plus 5 is 16. And then we divide by 2 and get x is less than 8. And I did not have to flip it because we divided by a +2, so no flipping necessary. And then we can draw a quick graph, -8, 0, 8. I'll just put those on here. The circle at +8, and we'll shade it this way. I just always shade it out to where the end of my arrow is. And then we could test by picking any point out here that we wanted to. Let's say that I picked 0. If I put that back in, I'd have 2 times 0 minus 5. And then 0 minus 5, so it'd be -5. And we're trying to see if that's less than 11, and it is. Negatives are always less than positives. So it's just a quick way to check. I'm probably not going to check all of the rest of these because I won't have room, but I want to emphasize that you can pick a number from your solution here and put it in and just make sure that we've shaded the right side, the correct side. Okay, so over here, our first 2-step inequality. What am I going to do first?
Add 4.
Add 4, good. So I'm going to have 3x is greater than or equal to 21. And then what do we do? Divide by 3, divide by 3. Do I need to flip anything?
Yeah.
Nope, everything was positive, so we're good. I'm just going to use the symbol the way it is. X is greater than or equal to 7. And do a quick graph. I'm going to get even lazier on this. I'm just going to put 0 and 7 on my graph to make this go quickly. Do I fill in the circle at 7? Yes. So we go in and fill that in. And then which way are we going to shade it? Good. You guys have got it. They're showing me the thumb switch direction, just like they're hitchhiking.
Help me.
Yeah, don't actually hitchhike. It's not safe.
Yeah. I know. It's really bad.
Okay, so that was that one. Now on number 2, what would we do first? Add the 5. So I'm going to add 5 to both sides and get that fraction by itself. So I'm still going to have x over 2 and then less than 8. And then what do we do?
Times.
Good. So I'm going to write this again just because it makes it easier when somebody looks at my notes later. I'm going to multiply both sides by 2. That cancels this out and we get x
16.
is less than 16. So we'll make a really easy number line. I'm going to put 0, 16. And then would I fill in the circle on this one? Nope. Just leave it open. And which way is it going to go? That way. They've got their thumbs out. So this is the correct direction. We want all the numbers that are smaller than 16 that would make this true. All right. So they're just going to add steps, which in theory we can handle because we've done all that equation stuff. But I always like to go through at least 1 or 2 of each type just so that our brains are hopefully remembering. So on number 3, I have 7 minus x. I want to get rid of the 7. Do I add or subtract the 7?
Minus.
Minus, because it's a positive 7. Very good. Can't trick you guys. And then when I bring this down, I'm going to bring down the negative with the x, and we can stick in a 1 there. We're going to need that for the next step. And then 4 minus 7 is going to be negative 3. It's just like 4 plus negative 7. So the reason I need that negative 1 is for the next step because we're going to divide both sides by negative 1 and we have to flip it. Good job. Got to make sure I don't mess up again. So the x will be over here, that cancels, and this is going to change to become less than. This will be positive 3. And so I'm just going to put 0 and 3. I'm getting kind of tired of drawing these. So put the circle at 3. We're not going to fill it in. And then everything to the left. Like I said, on your worksheet, the number line will be drawn for you, so you won't have to do that every time. You just have to solve it and put it on the number line. All right, so on number 4, we suddenly have parentheses. So remember, to get rid of those, we will distribute that 3 out. So 3 times x is 3x. We have minus, and then 3 times 5 is 15. And once you do that, this is just going to look like the 2-step equations, inequalities. I should call them inequalities. The 2-step problems we've already done. So what happens next?
Plus 15.
Plus 15. He's already working it out. And it is 27. And then we'll bring down the 3x. When I divide by 3, do I need to flip it?
No.
Nope, because it's just positive 3. Everything's just positive. It's all going to be good. So I'm going to have x is less than or equal to 9 as my solution that I box. And then I'll put that on my number line. So I'm just going to put 0 and 9. And since this does have an equal to bar, we will fill in the circle at 9. And then everything to the left. This is a lot for one day, but you guys are doing great. We're going to try to finish the notes up since I know I won't have anybody in class except for one tomorrow. All right, so if we go over to number 5, we're going to distribute negative 3 to both terms. And this is the part that we struggled with a little bit with the equations. So the negative 3x doesn't usually mess you up. But I have to think of this as negative 3 times negative 4. A negative times a negative makes it positive 12. So this is where a lot of people messed up the signs. So remember, if you've got a negative here and a minus there, those cancel to make this plus.
I thought negative times negative made it a double negative.
Double negative in math makes a positive, I know. So then we just solve like normal. So subtract the 12. So this is like negative 9 plus negative 12, which is negative 21. Are we going to have to flip it?
Yeah.
I got one no, one yes. What do you think?
It says yes.
So I have to divide by negative 3. So that's going to make this
No.
positive,
Yes.
and it's going to make this positive. So I think we're all thinking, yes, now we have to flip it because everything's changing signs. So x is less than 7. So we did need to flip on that one. Flip. Put my little note there. And then we make a quick graph. You're going to be so good at graphing by the time you're done with this. All right, so x is less than 7. We start at 7. We put the circle. We don't fill it in because it's not equal to. We shade all the numbers to the left of 7, which are smaller than 7. I normally break this into a couple of days, but we're just going to go for it. Now, the very last problem has x's on both sides. Don't freak out. We do know how to do that with equations. So we just need to get them all on the same side. So I have positive 4x here and negative 2x there. I need to add or subtract one of those to move them. So we can either subtract 4x and deal with negatives, or I can add 2x.
Add 2x.
So I like adding because then I don't have to deal with the negatives, which means I don't have to deal with flipping stuff. Thank you. And so then if I add 4x and 2x together, I get 6x minus 3 greater than or equal to 11. And now it just looks like all of our other problems. So what would I do next? Add 3. They're signing to me. Add 3. And then we get 6x is greater than or equal to 14. Divide by 6. And this will not divide evenly. So we're going to... So if you take 14 divided by 6 on your calculator...
It's going to get 2.3333.
Yeah, so we'll talk about that a little bit. So 14 divided by 6 is 2.333. So I know it's 2 and something. If you hit your math key, math, and then select number 1, frac, it'll take this answer and make it a fraction that's reduced. So it's going to say it's 7/3. So instead of making this a mixed number, we could just reduce this to 7/3. And you can do that by dividing by 2, dividing by 2. And then if you feel like it, you could make that 2 1/3. But the cool thing about high school is they let you leave improper fractions as long as you simplify them. The only time we have to do mixed numbers is in story problems. If you're talking about cups of flour, you might not want to do 7/3 and sit there with your third cup 7 times. You might actually want to do 2 whole cups and then a third. So that's where switching to this would be good. And then if you were putting this on a number line, let me just draw this in this tiny little space down here. I'm actually going to do 0, 1, 2, 3 on this one, so we can think about where 2 and 1/3 would go. So if I took between 2 and 3 and broke it into thirds, I'd have 3 pieces. Here's where 1/3 is. So that's where my dot would be. So basically between 2 and 3, but closer to 2. And then we want everything bigger going this way. So on your homework assignment, if you got a fraction, you'd have